Alrighty, welcome everybody. We're here to talk about the physics portion of the OAT. So once again, my name is Doug McLemore. I'm staff advisor and test prep specialist for the HPA, and we're here to help you guys sort of get the feel for kind of what level of information you need to memorize for the physics, as well as what kinds of problems that you're going to be facing. So without further ado, let's get started. Feel free to ask your questions and whatnot in the chat box or use your microphone. Either way is just fine. So reminder, the physics test comes right after the Survey of Natural Sciences section. Remembering that also that section is straight through. You don't have breaks in between each of the different subjects, and the subjects are not mixed together, so you have to plan accordingly so as not to funkify your particular score in there. So the physics test then comes about just before the lunch break, or the optional break that we're going to call lunch, and you get 50 minutes to do 40 questions. That's a little more time per question, about a minute and a quarter per question. So nice thing is here, the math you're going to run into on the physics is pretty straightforward. The problem you're going to see here is the math on the physics does not get a calculator, so you have to do everything by hand if you're going to be doing any calculations, which means keep the numbers simple. They usually keep them simple. Plus, much like in general chemistry, a lot of the problems are, they're set up but not solved. So you don't actually have to do the math involved. You just have to set up and put the numbers in the right place in an expression. So what kind of content will the test cover? This is basically across the realm of the entire Physics 7 or Physics 9 spectrum. Physics 7, it more like that content because it's not going to involve trigonometry to that great of extent. You might have a sine, cosine, tangent of 0, 30, 60, 90, 45. I forgot 45 in there. But that would be the extent of it. You're not going to be seeing anything more complicated. This is definitely algebra-based physics. So vectors, kinematics, statics, forces, basically, dynamics, rotational motion, like centripetal force, momentum and energy, like the work energy theorem, conservation of energy and momentum, waves, which simple harmonic motion would be things like pendulums and springs, fluid statics and fluid dynamics, where you got fluid moving through pipes, or fluid like an airplane flying in a body of fluid called the atmosphere. Simple machines, like when we're talking thermodynamics, we might see things like delta E equals heat plus work. Electrostatics, DC circuits, no AC here, so there'll be very simple circuits, and optics. So that's a lot of crap. That's a lot of content there. That can seem a little bit overwhelming when you really get down to it, and that's why we got to do a lot of practice. I'm going to try to point out some of the most important equations that you need to be familiar with. And let's start here. With kinematics, these are the equations that you're going to need to know and use. You've probably seen these, or at least some version of these equations, at some point in your schooling, where you'll plug in initial velocities or final velocities, displacements, time, or acceleration, and find one of the things. I would make sure you memorize these 5 equations. Memorize each of the 5. Now, I know it's tempting to say, well, I can derive certain equations, but deriving equations versus just memorizing these straight up, it seems like deriving it'd be faster. You don't have to remember as much, but the memorizing is really the key to getting questions solved the quickest. Other types of questions you're going to get that don't involve equations are questions like number 5. So they're saying, okay, refer to the data plotted in a figure where the acceleration, what is the acceleration between time 0 and 5 seconds? So we're looking at this, and we could just get this graphically. We don't have to do a calculation. We just have to remember the basic definition of acceleration. For those of us in here, do you remember what that definition of acceleration is? Change in what over time?
Velocity.
Change in velocity over time. So that actually makes this question fairly straightforward, because what is my change in velocity from 0 to 5 seconds?
5.
Sorry,
10.
Yeah, 10. 10 it would be my change in velocity. And so I would see, oops, wrong button. I would see that I would have my change in velocity from here to here, 10 over time, which is going to be 5 is in the positive or negative direction.
Positive.
Positive. So my best answer choice here is going to be what?
2 meters over second squared.
2. So A. But you can see how what they're doing is they usually do this, by the way, where they'll give you options that are positive and negative. So pay attention to the sign for sure. And then they'll do things like multiplication instead of division. In this case, I probably would have wrote this with positive 50 and negative 50 instead of positive 25 and negative 25, to be honest. But that is, be that as it may. So straightforward to get it from the graph. Sometimes they don't give you that. You'll have to know your 5 kinematic equations. Dynamics, this really comes from these 3 basic laws, Newton's laws. I bet you recognize them. The first law of inertia, the second law, which is force times mass acceleration, or forces mass times acceleration, and the third law, which is the action-reaction force. There's something I want to point out with the action-reaction force. If I have a box sitting on a table, the force pulling the box down and the force pushing the box up, is that an action-reaction force?
No.
Ah, good. I usually get people on this one. It is not an action-reaction force because the force down is due to the earth pulling on the book. The force up is the table pushing up on the book, which means there's not a pair of objects involved. There's 3 objects, one of those being earth. So note that that is not an action-reaction pair. And they like to throw that one on there to try to get people to say it is an action-reaction pair. It straight up is not. So good eye, I'm very happy to say. That's very good. Questions like 11, you see here, they're just basically asking us what the different forces are. So you've got 4 fundamental forces that get asked about. That is gravity and normal force, like we saw just now, as well as in the horizontal direction, what other forces might I see? Which one is included in question 7 and 11, by the way?
Frictional force.
The friction force. So if I've got motion, then I'm going to perceive a frictional force on that thing. Could be kinetic, could be static. And then the third force, or sorry, the 4th major force that you got to understand for this test is tension. So if there's strings and things around there, you might see tension. So normal force, gravitational force, frictional force, and tension are your big forces that you need to pay attention to for this particular test. So what do we think the answer is for this one? A kilometer applies a horizontal force of 2 newtons to a 10 Newton box, which slides across the floor at a constant speed of 3 meters per second. What is the frictional force? This is actually a trick question. What rule applies? The first law, second law, or third law with this one?
Not too sure.
It's a constant speed. So does it have an acceleration?
Okay, so not the second law.
Not the second law, it's the first law. So this is how they sort of plant a trick problem in there. They'll give you constant or 0 acceleration, which means we already know what this is. If she's applying a horizontal force of 2 newtons, then the force opposing that motion must also be
0.
Well, the total net force has to be 0. So the opposing force has to be 0, making our answer 2. Tricky, right? Not a hard question, but it looks like it could be harder than it really is. That's the DAT, or sorry, the OAT. No physics on the DAT. Oops. Torque. Got your favorite types of torque questions. Torque, basically, as long as you understand torque counterclockwise is equal to torque clockwise, you're in good place. So they're talking about this massless rod to maintain equilibrium, the following force in newtons, blah, 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 blah. So where is the pivot point of this particular rod, it's telling us it's right here. And that's the first thing I look for in all torque questions, is find my pivot point. And then if you recall, torque is really just the distance times the force applied. So let's see, which force here is clockwise? Is it the force up or the force down?
Force up.
So I can pop that in my equation, that I've got 5 meters times a clockwise force. What's the force torque counterclockwise?
Force down.
Which is going to be 3 meters from the pivot times a force of 100. So what's my force on this rod to keep it in equilibrium?
300 over 5.
300 over 5. Here's a trick. When you're doing fast math, don't multiply before you cancel. It's easier to cancel stuff out. So how many times is 5 going to 100?
20 times.
So that makes the math simpler. Now I can multiply and find my answer, which is
60.
60. So as a rule of thumb, whenever you're trying to do fast math, divide before you multiply, because that will almost always result in smaller numbers and make it easier to do that mental math. Groovy. Work energy, you're going to see your common relationships always with potential energy being gravitational potential energy, MGH, kinetic energy being 1/2 mv squared. I'm sure you've seen that. I know you've seen the work energy theorem. However, most people don't use it enough. Work is not just FD cosine theta. In fact, more often than not, you're not going to calculate work using FD cosine theta. You're probably going to calculate work from a change in kinetic energy or a negative change in potential energy. So keep that in mind. Work is probably better remembered as being delta KE or negative delta PE than it is force times distance. All right, so here we have a friction friction is neglected, which is pretty much most of the time. A 2 kilogram object that has fallen 10 meters. Has it gained potential energy as it falls? We've got a nice conceptual question.
It hasn't gained potential energy.
It's lost potential energy. Has it lost kinetic energy or has it gained potential energy? Or kinetic energy, I should say.
It's gained kinetic energy.
Okay. Will it have constant mechanical energy?
No.
It should, because of the law of conservation of energy. I should not lose any mechanical energy, because mechanical energy is kinetic energy plus potential energy.
Potential energy. Okay.
Yep. And so it's tempting to want to go up to those 20s because you see a 2 and a 10 in there, but what's wrong with both of them? How many joules is being exchanged? Easiest to use is potential energy here. Mass is 2, gravity is
9.8.
not on this test, it ain't 10.
Okay.
Something like this, 10 is good enough. And it's actually what they used to come up with answer choices. And then height was 10 meters. So that's not 20 joules of exchange, that's
200.
100. So the 20 is tempting, but the real answer is C. Again, tricky questions, but again, the math here is not very complicated for the physics section of the OAT. They try to keep it to a dull roar. Hydrostatics, everybody's fear. I think the reason people fear hydrostatics so much is because, not because the equations are hard to use or hard to interpret, it's that they can give you information in so many different ways, it's hard to tell what they're giving you. I think that's the biggest thing. For example, buoyant force. That's the buoyant force that's, lifting something up. They could also give it to you by saying, oh, the weight was reduced by 20 pounds or 20 newtons. When they say the weight was reduced by 20 newtons, what is the buoyant force? It's actually 20 newtons. Because the weight goes down by the same amount as the buoyant force. It is the buoyant force. So that's the way they get you confused on these things, is they throw you under the bus with all these different ways of referring to things. So the buoyant force could be given to you in 2-3 different ways, just in the phrasing. The other thing is like that volume of fluid displaced. They might say the volume of the object is 1 liter and it's only 50% submerged. So the fluid displaced is going to equal half the volume of the object. Or they might say a 2-liter object is completely submerged. So they're not giving you how much is displaced, they're giving you the volume of the object. So you have to do it in terms of that. So it's a lot of just little picky stuff with the wording of the questions. So you really should focus on wording of the questions when you're practicing this information. You also have to remember your basic unit conversions. Atmospheric pressure is equal to 1 atmosphere, or 760 millimeters of mercury, or 100 kilopascals. They could give it to you in pascals as well, but that one's an easy conversion from kilopascals to pascals. But know your units for pressure. They will interconvert. Now, 26. I'll tell you this in advance. This is a trick question. We have a pool. We have them saying the atmospheric pressure increased by a certain amount. What did the pressure at the bottom of the pool increase by? Is it going to change at the bottom of the pool what the pressure is?
No.
That's the trap. Because what is the pressure at a certain depth? It's the gauge pressure, which you're probably thinking about, plus the atmospheric pressure. So the pressure will change, and by how much is it going to change?
2 times 10 to the third.
It's just going to go up by the same amount. There's nothing to calculate here. Again, nothing to calculate except for just understanding that the depth pressure, the pressure at a certain depth is both the gauge pressure and the atmospheric pressure, not just the gauge pressure. Now we ignore the atmospheric pressure a lot when we talk about pressures under fluids, but that's because the atmospheric pressure is usually a constant, and at depth, it's usually negligible. Like if we go down 10 meters into a pool, that is already 1 atmosphere of pressure plus the additional 1 atmosphere, which means I've doubled the pressure by going down 10 meters, which by the way is a good rule of thumb, just to put it in there. 10 meters of water is 1 atmosphere. It's like adding 1 atmosphere of pressure. So I go down 200 meters. What's the pressure?
2 atmospheres. Or sorry, 20.
20 atmospheres plus 1, so 21 atmospheres. Because I've got that atmospheric pressure sitting on top of the water. So I'm adding 1 atmosphere for each 10 meters of water I go down. And one other number that you should definitely know, and I don't know why I didn't put this on the slide, the density of water is not 1 for physics. The density of water is 1,000 kilograms per cubic meter. That's the density we're going to be working with for physics. So in chemistry, you'll say it's 1, but in physics, you got to remember 1,000 kilograms per cubic meter for the density when you're plugging it in. All right, when we get into oscillations and waves, light, sound, all this stuff, some basic equations you're going to have to remember here is that the energy of a wave is equal to Planck's constant times frequency. The velocity of your wave is the wavelength times the frequency. You can combine those together to find the relationship between energy and wavelength, or energy and velocity for that matter. Although velocity for light waves is set. What is the velocity for light waves? AKA the speed of light.
3 times 10 to the 8th.
3 times 10 to the 8th meters per second. And what's the speed of sound? It's another good one to know. Normal conditions, 340 meters per second. Some good numbers to know there, just in case I have to plug them in. You should also know the order of the electromagnetic spectrum. From high to low energy, it goes gamma. Oops, I don't know what I'm writing there. It goes gamma, followed by X-ray, followed by UV, followed by the visible range from violet to red. That's why I always remember it this way, because ultra is above violet, infra is below red. So this goes from high to low energy. High to low energy there. And then you should also know the period of a wave is 1/frequency coming into the test. So a question like 23 is very straightforward, and they're even nice enough in 23 to give you the speed of light. What would I need to do to find this answer? We're being asked what wavelength is, and we're being given frequency. So what is the wavelength equal to, according to our second equation?
Velocity over frequency.
Velocity over frequency, which means I'm going to do 3 times 10 to the 8th over 600.
Yes.
600 kilohertz. We're not going to divide by 600. We're going to divide by 600 times 10 to the 3rd hertz. We always have to use our base units. Get rid of those prefixes. So note prefixes when they happen. Notice how like some of the answers are differing by 3 orders of magnitude. That might have something to do with it because they wrote it this way. And that one actually should be 5 million because there's a missing comma. So I don't know what happened there. So I would actually write it as 3 over 6 times 10 to the 2nd. There's my 100, 600 times 10 to the 3rd. There's my kilo, because this math is easy. This is going to be 0.5 times 10 to the what power?
3.
10 to the 3rd power, which is going to be which answer?
500.
B, 500. So word to the wise, use scientific notation and make sure you know from the math section your rules of exponents. Always use scientific notation on questions like this. It's going to make the math easier to do. Just makes math easier to do. Circuits, like I said, they're going to be some pretty basic circuits, just resistors and voltage sources, things like that. Got to know your basic rule of V equals IR. You also got to know Kirchhoff's laws, which the sum of currents in is equal to the sum of currents out, and the sum of voltage drops around a closed loop is 0. To answer pretty much any question you're going to run into on the OAT. So they're asking here, where in the circuit would a voltmeter be placed to measure the voltage across R? So this isn't even a question saying, how am I going to, or what is the strength or something like that. It's just saying, how do I measure? So you'll get occasionally these more experimental based questions instead of these quantitative questions. So go through each of the answers. Would I put it across AB to measure R3?
No.
CD?
Yes.
That seems pretty good because it isolates that from the voltage source. And that's really when you're doing measurements, what you want to do. Isolate the thing you're trying to measure from the voltage source itself. And make sure you've only got one circuit element in between those 2 points. In series at point E, that doesn't isolate jack squat. So yeah, all those. It's series, and series. That's not going to do anything because it doesn't isolate your device. So yeah, from point C to point D. So if you're seeing that a lot of these questions you're going to run into are not complicated, they're just like, they require you to know a few basic rules. So you're not going to see a ton of math that you actually have to do full out. Magnetism. There are 2 rules you need to know for magnetism. There's the hitchhiker rule, and I'm going to turn my video on for this. If you're being asked, what does the field look like? You use your thumb to stick it out like this, because the field lines are your fingers and they're wrapping around your thumb basically. So you're going to get circular field lines. The slap rule is what you use when you're being asked for what is the force. And I do it this way. I know some folks will actually try to do this. And I don't know about you, but this is hard for me to keep my hand in this orientation. Plus, I tend to let my fingers like warp when I do this. But if I do this, make an L shape with your hand and then keep it flat, everybody can do that without a problem. So your fingers are still the field lines, but now they're linear. Your thumb is still the flow of charge, and the palm is that force. The palm is going to show you the direction of the force. So first question first, long straight horizontal wire with current in it produces a magnetic field. Am I being asked a hitchhiker rule question or a slap rule question with this question?
The slap rule?
Are they asking me for a force or a field?
Oh, the hitchhiker rule.
This one's the hitchhiker rule because they're asking me to describe the magnetic field. And that's always the thing you want to do. Since this is the one that determines the field lines, this is the hitchhiker rule. The slap rule is you're looking for the force. And that right there will save you all kinds of headaches because most of the time, that's what people do wrong in these questions. You're thinking about the wrong right-hand rule. So when I'm thinking about this right-hand rule, my fingers are pointed in circles. So are they radially away from the wire?
No.
No, they're wrapped around the wire. So A is out. Same magnitude at all locations. Is that ever true about magnetic fields?
No.
No. Points in the same direction above and below the wire. Above and below the wire.
Yes.
Is it the same direction though?
Oh, no.
Above the wire, it's out. Below the wire, it's in. So C's out. At any point is perpendicular to the plane containing the points and the wire.
Yes.
Yes, because that's it's a weird, really terrible way to describe circular. And then E points radially, again, we get rid of that. It's easier actually to get rid of A and E, or A, B, C, and E than it is to realize that's what they're describing as circular in a very awful way, because that's just a terrible description of circular. So the key to magnetic field questions, pick the right rule, hitchhiker versus slap. All right, and then finally, optics. You got to know Snell's law because you're going to be seeing Snell's law questions about angle of reflection, angle of refraction type stuff. You should know the thin lens formula, 1 over focal point equals 1 over O plus 1 over I, and then know all of the focal point rules for all 6 types of optic devices, which is flat, mirror, and lens, concave, mirror, and lens, convex, mirror, and lens. So you need all 6 of those. You need to know all 6 of those rules. For the image, the rule is very simple. RIP VUN. RIP stands for real, inverted, positive. So when the image is positive, that it's going to be a real image, it's going to be inverted. And then you got to know virtual, upright, negative. So when the image is negative, it's virtual and it's upright. So real, inverted, positive, virtual, upright, negative. Rip Van Winkle is how I've always remembered that. And then for the object's easy. It's always going to be positive, and if it's at the horizon, if it's very far away, it's just going to be infinity. Because how do I deal with that? What if it were at infinity? What is 1 over infinity equal to?
0.
0. So it just cancels out of the equation. Then, of course, know your magnetic or magnification question, which is negative I-O, or negative I over O, or hi-ho, H-I over H-O, being the heights of the objects. So a thin lens produces a virtual image which is smaller than the object. It must be that blank. So we're basically being given some information about this image. So what have they told me about the image? It is virtual and it's smaller than the object. So what does that virtualness tell us about I? It's a negative image if it's virtual.
So I is small.
Say again.
Oh, I is negative.
We know that I has got to be negative. It's telling us I is negative. And then it says it's smaller than the object, which means, okay, let's say, what does that mean? Magnification is going to be, absolute value of the magnification is going to be greater than 0 or less than 0?
Less than 0.
It's going to be less than 0. Or sorry, that was the wrong number. Sorry, greater than 1 or less than 1 if we're talking magnification.
Less than 1.
Less than 1, because it's got to be a fraction of its original height. So here's where I start just picking numbers, and I go with it. So let's say I've got a -5 for my image. What then could be my O? So they're telling us it's a virtual image, which also tells us it's upright, which means my magnification needs to be positive. So that's going to happen if I've got -5 over O. So what could be a possible value for my object to make that magnification less than 1?
10.
Okay, let's say plus 10. Then what would that make my focal point? If I've got 1 over focal point equals 1 over 10 minus 1 over 5. So that tells us this is 2 over 10. So my focal point is 1 over focal point is equal to -1/10. Or my focal point then is equal to
-10.
-10. So it looks like, let's check our answers. Object must be inside the focal point of a converging lens. Object must be outside the focal point of a converging lens. Well, not if the value is -10 and the image is at -5. Or sorry, the object is a +10. This is not an inside-outside case. The lens must be diverging, and here's what I mean by the rules of the focal points. If you see a negative focal point, you should know that it's a diverging lens. So that's looking pretty good. The object is infinitely far. Nope, doesn't have to be infinitely far. And the object must be far from the optical axis of a converging lens. It's not converging, it's diverging. There we go. So a lot of times with these questions, you just got to be creative and pick some numbers that fit the parameters you have. Don't be afraid just to make some numbers up. It's like, it's equivalent to what we're going to call in math, the plugging in technique. Because whatever numbers you pick, if you're following all the rules that you know, then you will still get the right answer, regardless of what numbers you picked. I could have picked the image at being -50, and I could, and some other value for the object, still would have gotten the question right. So that's a run through of just what you might expect when it comes to the physics portion of the DAT. It's going to be a lot of qualitative questions with a handful of mathematical questions in there. So let me open the floor up for questions. What kind of questions do you guys have for me about what to expect when you come into physics?
So like you mentioned, it's not too in-depth with the quantitative. So you suggest that we should just really know our basics extremely well.
Yes. You're gonna get some calculations. I can't avoid that, unfortunately. When we do talk about the math section, some of the same things we're going to see in the math session are going to be applicable to the math part of the physics, but the conceptual ones are the ones that get people the most, because it's just like some stupid little rule that you didn't remember is what they're asking about in the question. Like, as an example, like here, just making sure you understand that the pressure at depth is the atmospheric pressure plus the gauge pressure is why people get this question wrong. It's just it's a dumb little rule that if you've forgotten it, it's easy to get this question wrong. And they put the trap answer right up front. That's their tendency with the physics, is to test little rules that might be really dusty in your memory.
Are all these topics gonna have like an equal portion in the physics, or are optics probably gonna be the main focus?
No, they're going to be pretty evenly distributed. You'd think that the physics or the OAT would have a lot of optics on the physics, but it's like 1 or 2 questions. And that's part of the issue with the physics on this test is it's such a huge span of information that you're going to see questions that pop out of all of these. Like I didn't even touch on everything that could be on the test, just because we only have an hour. I could talk about this for like 3 days, but as a whole, these are some of the more common topics, but yeah, it's going to be pretty evenly spread.
Are there
Go ahead.
any materials or resources that you could suggest?
Well, the first thing I would suggest is come take a practice test, or no, don't come take a practice test, but sign up to take a practice test online, which I will moderate online on July 24th. You can do that at the testprep website. Just to get a good feel for how the test works. As far as resources go for the OAT, they're a little bit hard to find. But I think the most common ones people are using these days is Crack OAT or OAT Bootcamp. It's lots of problems. It's basically lots and lots of practice problems and some supplemental videos. If you have DAT materials, you could use those and just supplement it with some physics content online. You can do that with like, Khan Academy, or there's some physics series of physics videos on YouTube as well. Chad's videos are mostly for DAT. I think they're all for DAT. The big companies don't have a lot offering for you. Like if you're looking to Kaplan or Print and Review, they're unfortunately got limited resources. Print Review doesn't have anything. They will often just do tutoring and then toss in an extra physics book on top of it, because they'll just use their DAT materials for it. And then Kaplan does have a OAT book, but their problem is they have a limited amount of practice materials, unfortunately. So you don't have a lot of choices with OAT. I would suggest probably looking at something like Crack OAT or OAT Bootcamp, like I said.
Okay, and I just started studying for the OAT. So would you recommend to take the mock test just to get my baseline?
Yep. You gotta know what you're studying for. So it's a good way just to get yourself familiarized with the style of test, the speed at which you have to work, and the sort of breadth of content.
Okay, thank you.
Sure thing. Our next session is going to be 2 weeks from now, July 26th in the evening. We're back on the evening time slot. And we're going to be basically looking, and we'll be back with the DAT folks as well, because it's the same section. But it's really how to do the reading comprehension without reading, because for the most part, actually reading the whole passage is not a good idea. So reading comprehension class about how not to read. That's basically it. Then of course we have that test, like I said. You can always drop into Monday office hours between 8 and noon. The link you can find at the test prep website. If that is it, if there's no other questions, let's call it a day.
Thank you.